In the course of doing the homework, you're going to encounter problems that raise the following questions. What if the denominators are binomials or trinomials? The previous example I gave in adding or subtracting rational expressions gave you an example where the denominator was a monomial, in which case we just had this to break up into primes and we could find the lowest common denominators. What if it's not a monomial like this? What if it's actually a binomial or trinomial? For example, say we have something like 7 over p plus 5 minus 6 over p plus 8. Now how do we find the lowest common denominator? Remember, these cannot be subtracted until we have the same denominator for each. Well, in this case, this binomial is this is completely factored down here. So this is a prime polynomial already, meaning that p plus 5 can't be broken down any further. And same thing over here, p plus 8, that's a prime polynomial. That cannot be factored down any further. So what this means is that our least common denominator will have to have at least one factor of this and one factor of that. We're going to do that. Let's see, we'll give ourselves a little bit more room, minus that. Okay, so we have to have at least one factor of p plus 5 down here, and then we have to have at least one factor of p plus 8 down here. Same thing over here, p plus 5 times p plus 8. Now all of our prime factors are accounted for, but for the first fraction I multiplied the denominator by p plus 8, so I've got to do the same thing in the numerator in order to keep the expression equivalent. Over here I multiplied my denominator p plus 8 times the factor p plus 5, so I've got to do that in the numerator as well, p plus 5. And now you can see that if I were to cancel out the common factors on top and bottom, I would be left with what I started with. But since I'm expressing them both in the same common denominator, now the numerators can be subtracted. And I'll go ahead and do that. This would be 7 times p plus 8 minus 6 times p plus 5 all over p plus 5 times p plus 8. And you could go ahead and distribute this out. Let's go ahead and do it. 7p plus 7 times 8 is 56 minus 6p minus 30 all over p plus 5 times p plus 8. Combining like terms here, we would have 7p minus 6p, that just gives us p, and 56 minus 30 leaves us with 26 all over p plus 5 times p plus 8. And there are no common factors here that can be canceled out on top and bottom, so that's in its simplest form. Let's take another example where the denominator is a trinomial, not just a binomial. Say we have t plus 5 over t squared minus 9t plus 20. We want to add that to 6 over t minus 4. Noticing that the denominators are not the same, we're going to have to find the least common denominator again. In order to find the least common denominator, the denominators have to be factored into primes. In this case, t minus 4, that cannot be factored down any further. It's already a prime polynomial. But we know that we will then have to have at least one factor of t minus 4 in our new denominator. This, however, can be factored. This trinomial can be factored. And the question is, let's see, how can I factor this? I want it to end up looking like this. Okay. What are two factors of 20 that would add up to minus 9? Well, I know they're both going to be negative because my last term is positive here. And 4 and 5, negative 4 plus a negative 5 will add up to a negative 9. So let's do that. Now these two factors are prime factors. Neither of them can be broken down any further. So we know that our new denominator is going to have at least one factor of t minus 5 and one factor of t minus 4. This also requires a factor of t minus 4. So we will only need one factor of t minus 4 in our new denominator. So t minus 4, and the other factor we need is t minus 5 and a t minus 5. Over here, I did not have to multiply the denominator by any other factors than what was already included, so I'm just going to keep my numerator the same. Over here, my denominator, I had to multiply by a factor of t minus 5. So that means I've got to do the same thing up top. And of course, multiply that by my original numerator. Now these denominators are the same, and they can be added. So I'll have t plus 5 plus 6 times t minus 5 all over t minus 4 times t minus 5. I can multiply this out and combine like terms. So I have t plus 5 is going to give me a 6t minus 30 all over, again, t minus 4 times t minus 5. And I can combine like terms at this point, which gives me 7t. Plus 5 minus 30 gives me a minus 25 all over t minus 4 times t minus 5. None of these factors are in common. None of them can be factored down any further. That's as simple as the expression gets, and we're done.